Hi, good morning. Today's video we are going to evaluate this integral natural log of sine x dx, the bound from 0 to pi over 2. If you would like to take a try, just pause the video when you ready, come back to see how to solve this problem. Okay, let's start. The first thing we should know about this integral, there is a sine x inside of natural log. Okay, so the 90% we should use a substitution, okay, for this integral to solve it, because to use the by part we should have two functions here to reduce the term to one term, because in this case the easiest way to do, we are going through substitution, okay, as a variable change, right? So this one. And the second thing we should know about it, there is a connection between sine x and cosine x. So there is the connection is like sine 2x equal 2 times sine x multiplied by cosine x, okay? And then also another one, natural log of a b equal natural log a plus natural log b. We are going through these rules to go to the solution. So what's the idea to give us to solve? So let's start with a substitution now. Let's put x equal pi over 2 minus theta. If you differentiate this one, we are going to find dx equal minus d theta. Let's go to the bounds. If you give x equals 0, then theta takes pi over 2. X equal pi over 2, theta goes to 0, right? Let's log into this integral. I equal pi over 2, 0, natural log of sine pi over 2 minus theta minus d theta, right? We are going to switch the bound. We put the upper bound in the lower bound. The lower bound goes to the upper bound. It comes with a negative sign. Negative sign with negative sign becomes positive sign. So the positive from 0 to pi over 2, natural log of sine of pi over 2 minus theta equal cosine theta. This is the connection between sine x and cosine. There's pi over 2 between them, okay? So d theta. This is our new integral. How to make this connection, how to transfer this cosine theta into sine theta or sine x. So we are going to use this one in order to find it, okay? And also this one, you can rewrite it in this form, natural log cosine x dx. If you change it from theta to x variable, you will be not change the value of the integral, because they're the same. You can put it again equal from 0 to pi over 2 natural log of cosine y dy. It will be true, okay? And then because the value never change as long as you have the same bound, okay? So let's put these integrals together. The first one, which is natural log sine x, and then second one, which is natural log of cosine x. Let's put them together, which is I plus I equal to I from 0 pi over 2. Let's put these integrals separately and then put them together into one integral, okay? Sine x dx plus 0 pi over 2. We are going to show all the steps, that's why we're doing separately first, then we put it together into one form, okay? Sine x dx. Now our integral become 2i equal from 0 pi over 2 natural log of sine x multiplied by cosine x okay, dx same time equals 0 pi over 2 natural log of this one equal what? This one equal this one, okay, but take these two divided by this one, it gives you 1 over 2 sine 2x, right, dx. We are not going to leave this one like this. We are going to change to do the substitution again second time, because if you take a look here, you have 2x, here you have x. To go back to the original function, which is 6, which is sine x. So let's put 2x equal like phi, right? Let's differentiate this one. So d phi equal 2 times dx. If you are going to do the change the bounds as well, so x equals 0, phi equals 0 as well. If you put x equal pi over 2, that means phi equal pi. Okay, let's log into integral. So 2i. So this one, let's put it natural log 1 over 2 plus natural log of sine 2x. We are applying this rule, okay, which we have here. We can put it natural log 0 pi over 2 over 2. Let's put it separately, individually, okay, plus from the 0 pi over 2 natural log of sine. Don't forget we are doing the substitution here. From 0 is 0, from pi over 2 is pi, because we are going to change this integral into phi variable. So sine phi, okay, d phi over 2. This is new changing, okay. Let's put this one to outside, which is natural log 1 over 2, 0 pi over 2 dx, because it's a constant, plus, okay, this is the question here. We see this integral is almost the same, but the bound is different. Let's put this one first outside, 1 over 2, 0 pi. Let's change sine phi to sine x dx. It's the same thing, okay? Because the changing variable, as we said previously, it will be not change the value of the integral, okay? If you take a look here, this is I, okay, I over 2. This one, if you take a look here, is the same, but the bound is different. Look to the graph now. We are going to the graph to show. You see, this is the graph of natural log of sine x. It's going like this. This function is a negative function because it's located below the OX axis, okay? So, and then is increasing until you get the, increasing until you get from 0 to pi over 2 is increasing, then is it ends in 0 because the pi over 2, natural log of pi over 2 equals 0, okay? It becomes 0 here at this point, then keeps going down, decreasing, okay, until you get the pi axis, okay? What do you think here? This is pi over 2, this is symmetry to pi over 2, okay? This is half of this area equal this area. So the integral from 0 to pi, you see, integral from 0 to pi, this area, equal 2 times from 0 to pi over 2, because it's symmetry. You see, this area equal this area. So we don't have to do the substitution again, third time. Just we'll go directly to the graph. We take in this area 2 times, then plug in into our integral. So our integral become 2i equal natural log 1 over 2, natural log 1 is 0, minus 2, natural minus natural log 2. We are applying again this rule, natural log a over b equal natural log a minus natural log b, right? So don't forget this one is pi over 2. Okay, by doing this one, this is easier. So plus over 2 times 0 pi over 2. Now from 0 to pi equal 2 times 0 pi over 2, because it's symmetry for the pi over 2, okay, axis, okay, is a vertical for the x, okay, it's parallel to y, okay. So symmetry to pi over 2, let's put it sine x dx equal minus natural log 2 is 1 pi over 2 plus 1 over 2 times 2 equal 1. So that's mean, what is this? This is I plus I. Let's put our integral here. 2I minus I equal pi over 2 natural log 2. So I equal pi over 4 minus, don't forget the sign minus here, okay? Okay, this is pi over 2, yeah, this is pi over 2, and then this is pi over 2, 2 goes, so become I minus pi over 4 natural log 2, okay? No, you get the integral 2I minus I is I, okay, I minus pi over 2 natural log 2. This is the value of this integral, okay? Thank you for watching. I see you in next video. Bye.